Hi, this is Samigda and I will be explaining question number 1 of homework 4. Okay, so what do we have in question number 1? We have been given y equals to gx as follows, and we have been given the density function of x as to this. So what we need to find is the density function of y and distribution function of y in terms of distribution function of x and density function of x. So we can draw y equals to gx as this. So we can see for x less than 0 it is 2, and it's 0, it is 0. For x is between 0 to 1 it is 0, and for 1 to 2 it is going in -1, and for x is greater than 2 it is -1. So what we can observe is that for y equals to gx is between -1 and 2 for any x. So tell the distribution function of y is for equals to 1 for y greater than equals to 2, and 0 is for y less than equals to 1, -1. Now we will see the density function distribution functions at the corners. So for y equals to -1, y is less than, this can be written as 1 minus for y is less than equals to -1, it can be represented as 1 minus x less than equals to -1. So it can be represented 1 minus distribution of x at 2. For distribution at y equals to 0, it is between, probability is between when x is in 0 to 1, y is 0. So it can be written as the distribution of x at 1 minus distribution of x at 0. Now for y equals to 2, when it is probability y less than equals to 2, when is y 2 equals to 2, it is 2 for x is less than 0. So the probability of distribution of y at y equals to 2 is fx0 for y between 0 to 1. Again I am taking the same configuration as above. So y between, for y 0 to -1, it can be written as 1 minus x. So distribution of y for y equals to 0 to 1, between 0 to 1, it can be written 1 minus distribution of x in 1 minus y. So now for y between 0 to 2, y between 0 to 2, y is essentially 0. So what it can be written, so distribution of y between, for y 0 to 2 is 1 minus fx0. So now the distribution of y can be written as 0, y is less than -1, 1 minus fx for y between -1 to 0. For 0 to 2 it is 1 minus fx. Distribution of x at 0 for y greater than equals to 2 is 1. The fy can be written as uy minus 2 plus 1 minus the distribution of x at 0 multiplied by uy minus 2 uy plus 1 minus fx 1 minus y uy minus y plus 1. Now the density function can be written as taking the derivative with respect to y, distribution function derivative. So the density function of y can be written as, for y equals to -1, it is 1 minus fx2 del y plus 1. For between -1 to 0, it is fx1 minus 1, as simple as that. For y equals to 0, it is fx1 minus fx0 into del y. For 0 to 2, it is 0, and y equals to 2, it is fx0 uy minus 2, and 0 otherwise. So the density function can also be written as 1 minus fx2 del y plus 1 plus fx1 minus y uy minus uy plus 1 plus fx1 minus fx0 del y plus fx0 del y minus 2. So the density function can be drawn as follows. We have impulse at -1 with an area of 1 minus fx2. Then we have an impulse at 0, -1 to 0, it goes as a density function fx1 minus y. At 0 we have an impulse with an area of fx1 minus fx0. From 0 to 2 it is 0, and at 2 we have an impulse with an area of fx0, and this is the distribution function. So we can see at -1 it starts from 1 minus fx2, and then it goes up to 1 minus fx1. From 0 to 2 its value is 1 minus fx0, and then it from y greater than equals to 2 is just 1.